Welcome back to the Deep Dive. Today, we're digging into something pretty radical in free transportation. Swarm logistics.
Hmm.
Our sources are talking about this as like a real machine economy taking shape. It's about creating decentralized AI, both logically and physically, specifically for moving goods. The basic idea, imagine every truck, every van out there, not just following orders from HQ, but acting as its own business, an autonomous economic agent, planning routes, negotiating prices, making its own decisions. It's a huge shift in thinking. But, you know, there must be a reason the industry is looking at this. What's so broken about the way we manage fleets now, the centralized way? Why the need for such a, well, drastic change?
Yeah, it's a great question. And the core issues are really baked into the architecture itself. See, the traditional model, it funnels all the operational data, every location ping, every load detail into one central system. Now, if you're running a logistics company and your competitors are using the same platform, or even if it's just one company managing its own fleet centrally, you immediately hit this wall of distrust.
Right. Nobody wants their rivals seeing their routes, their customer lists, how full their trucks really are.
Exactly. Sharing that proprietary data is a massive hurdle. And beyond trust, you've got a resilience problem, that central server. That's your single point of failure.
If it goes down.
The whole fleet's efficiency tanks. Or worse, it's a single juicy target for cyber attacks. One breach could cripple operations. And maybe the biggest day-to-day issue is agility, or the lack of it. Logistics is all about reacting fast to what's happening on the ground, sudden traffic, a breakdown, a customer needing a last-minute pickup.
And the central plan can't keep up.
It struggles, yeah. Decisions come top-down. The driver spots a problem, radios back, waits for someone in an office to maybe replan, then gets new instructions. It's just too slow. Way too slow for how dynamic things are now.
Okay, so the old way is brittle, slow, and breeds distrust because of that central data pot. So getting rid of the center. How does the swarm model actually work then? What does this look like out on the road?
Well, the inspiration actually comes from nature. Think about ants finding food or birds flocking. There's no central bird leader dictating every wing flap.
Right, just simple rules everyone follows.
Exactly. Simple local rules lead to this complex, really efficient group behavior. Swarm logistics basically applies that idea. You completely ditch the central server. Instead, each asset, the truck, the van, maybe a drone someday, becomes its own intelligent software agent. It's programmed with a simple goal: maximize its own utility.
Utility meaning?
Usually profit, like maximize earnings per mile, cut down on driving empty, hit delivery targets efficiently. It's acting in its own best interest, economically speaking.
Okay, that makes sense. Hundreds of little capitalist trucks driving around. But wait, if they're all self-interested and maybe owned by competing companies, what stops them from just chaos? Or undercutting each other into oblivion?
Right.
How do they coordinate without a boss?
That's where the second piece comes in. And it's really the key enabler: blockchain, or distributed ledger technology, DLT. The DLT network becomes the neutral playground, the rule book. It's a shared, tamper-proof record of everything, and the rules of engagement are baked into smart contracts.
Okay, smart contracts. But if I own Fleet A and you own Fleet B, why do I trust your agent isn't somehow gaming the system on this blockchain thing? Why trust the contract?
That's the beauty of it. You don't trust your competitor. You don't have to. You trust the code.
The code itself.
Yes. The smart contract lays out the protocol, say, the rules for an auction to pick up a load. That code is visible. It's locked on the distributed ledger. Everyone can check it. It runs exactly as written every single time.
This is like code is law in this context.
Precisely. The blockchain guarantees that the auction runs fairly, the assignment is secure, and there's a permanent, unchangeable record of the whole interaction. It replaces the need for a human broker or even lawyers arguing over contract breaches between companies.
Okay, I'm starting to see it. Trust the protocol, not the player. So we get why we want this decentralized brain. But where does it live? If it's not in the cloud, what's actually on the truck making it smart?
Right. It's physically decentralized, too. The agent software, the AI, it runs on what's called an onboard unit, an OBU. Prototypes often use things like Raspberry Pi 4, small, powerful computers right there in the cab. Longer term, the vision is this just becomes an app running within the vehicle's own software system, a software-defined vehicle, or SDV.
Okay, so a mini computer in the truck.
Yep. And that OBU is constantly monitoring the truck's state GPS location, fuel level, available cargo space, even driver hours. And critically, it uses that data to make decisions autonomously.
Mike.
like adjusting the route slightly to avoid a new traffic jam or calculating the absolute best price to bid for a nearby delivery job that just popped up on the network. Because the decision engine is on the truck, each vehicle genuinely becomes its own profit center. That's the physical decentralization part. It's not just sending data up, it's thinking down at the asset level.
But historically, getting that smart routing meant sending all your sensitive data, where you are, what you're carrying, where you're going up to some central platform. If these agents are making decisions locally, how do they keep that data private? How does a company protect its secret sauce?
That's actually one of the biggest advantages here. It uses edge computing. The AI models, the complex calculations, they happen on the device, right there on the OBU.
So the sensitive stuff doesn't leave the truck.
Exactly. Your proprietary data, how you load your trucks, your specific customer locations, it doesn't need to be uploaded to a central server where a competitor or the platform owner might see it. Data sovereignty is built in by design. And these agents have some pretty sophisticated AI on board. The sources mentioned tools like Cargo Quant.
Cargo con.
Yeah, it's an AI vision system. Uses cameras inside the truck to automatically figure out exactly how much space is left, weight distribution, even analyzes how things are stacked.
Okay, and the agent uses that info to bid, but without revealing the details of the cargo to the whole network.
Precisely. The agent knows the exact available capacity, calculates its bid based on that internal knowledge, but only broadcasts the necessary non-sensitive info, like I have 10 cubic meters available, to the auction contract. There's also stuff like data morpher. Think of it as a universal translator on the truck. It can take unstructured info, like maybe an old school freight request sent as a PDF email attachment.
Which still happens all the time.
Right. And it automatically converts that into a structured format, like EDI, that the agent software can immediately understand and act upon. Again, all processed locally, keeping the data private.
Okay, so the truck's got its own brain, its own eyes, with Cargo Quant, its own translator. Now, how does it actually get the jobs? You mentioned auctions. How do you design an auction where everyone bidding honestly is actually the best strategy? Seems tricky.
It is tricky, and that's where mechanism design theory comes in. It's sometimes called reverse game theory. You're essentially designing the rules of the game, the auction, so that the optimal strategy for every rational, self-interested agent is to be truthful.
How does that work in practice?
Well, when a transport order gets broadcast on the network, eligible agents submit their bids, essentially their true cost and availability, to the smart contract. The contract then uses this carefully designed mechanism. It could be a Vickrey auction or something more complex
Okay.
to assign the load. The key is that the rules ensure the agent maximizes its own profit by bidding truthfully. And this simultaneously leads to the most efficient outcome for the network overall, like the lowest cost or the fastest reliable delivery. It aligns self-interest with system efficiency.
That sounds clever, but what about cheaters? The Byzantine agent problem.
Yeah.
What stops an agent winning a bid with a super low price than just not showing up or canceling right before pickup? That could wreck the whole system.
Right, that's a critical point. And the answer lies in tying economic consequences directly into the smart contracts. It's about making cheating unprofitable. When an agent submits a bid, the system requires them to lock up a deposit, like putting money in escrow digitally.
Okay, a security deposit.
Exactly. And if that agent wins the bid but then fails to follow through, they don't show up, they violate the terms. The smart contract automatically slashes their deposit.
Slashes.
Yeah, the funds are confiscated, gone. Maybe they get redistributed to the party that was harmed. Maybe they're just destroyed, burnt. The point is, there's an immediate automated financial penalty for breaking the rules. That's a much stronger guarantee than relying on reputation or legal threats later.
Got it. Skin in the game, enforced by code. And for big global operations, you mentioned the blockchain matrix. Why is that needed if we have these smart contracts?
Well, the reality is you might have different companies or different regions preferring different underlying blockchain platforms. Maybe one uses Ethereum, another uses Hyperledger Fabric, a third uses something else.
Right, you want silos.
Exactly. The blockchain matrix acts like an interoperability layer. It allows agents built on different DLTs to still talk to each other, participate in the same auctions, and coordinate seamlessly across networks. It keeps the marketplace unified.
Okay, so we have this really sophisticated, decentralized system built on agents, edge AI, mechanism design, and blockchain. It sounds good in theory, but how does it actually perform compared to the old centralized way? What did those field trials show?
The results from the sources are pretty compelling. Let's look at scalability. Central systems hit a wall. They max out based on server power. Swarm logistics, it scales horizontally. Every new truck, every new agent you add actually adds computing power and decision-making capacity to the network.
Makes sense. More agents, more distributed power. What about resilience?
Big difference there too. Remember, the single point of failure. Swarm doesn't have one. The field tests, like those Stuttgart trials in late 2024, specifically simulated failures. They just, shut down an agent's OBU completely, and the system just kept running. Other nearby agents picked up the slack. Transport orders got rerouted automatically. The network absorbed the shock without missing a beat. It's inherently more robust.
Okay, resilience is great, but let's talk bottom line. The sources mentioned cost reductions of, 15% to 35%. That's huge. Where does that come from? Is it just finding cheaper routes?
It's a mix, but the biggest drivers seem to be slashing empty miles and just much, much better asset utilization.
How so?
Because the agents are constantly scanning for opportunities locally and reacting in real time. An agent delivering a load can see, hey, there's a pickup available near my drop-off point going vaguely back towards my base. It can bid on that immediately filling capacity that a central planner working with yesterday's data would likely miss.
So it turns downtime or empty return trips into revenue opportunities automatically.
Exactly. That 15-35% saving, even in relatively small fleet trials, shows the power of letting the assets constantly optimize their own schedules and negotiate backhauls autonomously. Less wasted fuel, less wasted driver time, fuller trucks.
That kind of efficiency gain really throws down the gauntlet to the current platform model, doesn't it? Where companies often feel like they have to hand over their data and control to these big tech platforms to get any optimization benefits.
Absolutely. And that points to what might be the most appealing aspect for businesses: decision autonomy and sovereignty. Meaning the company running the trucks still sets the rules for its agents. They encode their own business logic, their required profit margins, their customer priorities, their rules about driver breaks into their agents' programming. They aren't handing decision-making over to some black box algorithm run by a third-party platform. Their agent is their representative, acting on their behalf within the rules of the shared marketplace protocol. Control stays with the asset owner.
So it flips the model from platform-centric, where the platform holds the power,
To protocol-centric, where the power lies in the open, transparent rules of interaction that everyone agrees to follow, enforced by the code. It could level the playing field, allowing smaller carriers to compete effectively with huge fleets, coordinated by the protocol, not a middleman broker.
And looking even further out, this whole agent-based, decentralized structure seems almost perfectly designed for,
Yeah.
full automation.
Precisely. It's inherently future-proofed for autonomous assets. When self-driving trucks become widespread, or warehouse robots, or delivery drones,
They just plug in.
they can just plug into this network. They already are autonomous agents. They can immediately start participating in the marketplace, bidding for jobs, earning revenue via the smart contracts, potentially with zero human intervention needed for the economic side of things.
So wrapping this up, we've journeyed from this old model, a central control tower, kind of slow, riddled with trust issues, to this vision of a decentralized web, where the trucks themselves are smart, independent economic players. They're their own little profit centers, making real-time decisions, coordinating through rules baked into code on a blockchain.
Yeah, and while logistics is maybe the first big industry to really try and build this machine economy, the underlying pattern, lots of self-interested players needing to share resources efficiently and trustlessly, that pattern applies almost anywhere.
Which brings us perfectly to our final thought for you, the listener. If trucks can use blockchain to negotiate their own work and make their own money, what's next? Think about other shared infrastructure. Public EV charging stations. Could they become autonomous agents negotiating prices based on grid load and demand? Distributed energy grids? Even city traffic signals coordinating flow based on real-time negotiation between vehicles. What happens when code, not companies, starts coordinating how we allocate and use resources all around the globe? Something to think about.